So in this video I'll talk about pure capacitive circuit, how they can be solved effectively. Okay, what is the equation? So let's start with the pure capacitive circuit. Means a capacitor is directly connected across an AC source. Okay, capacitor is directly connected across an AC source, capacitance C, and the AC source is given by V0 sin omega t. Let at some moment the charge on the capacitor is Q and I current is flowing in the circuit. As per the diagram, I can say I is dq by dt, and using Q as CV, C into V, which is C V0 sin omega t. On differentiating, I'll get I as C V0 omega. Differentiation of sine will be cos omega t. Okay, so we can also write this as V0 by 1 by omega c. So why we are doing this? ऐसा हम क्यों कर रहे हैं? क्योंकि हम रेजिस्टेंस की जगह कुछ रखना चाहते हैं. In the previous video it was V0 by R. So R की जगह किसने ली? R की जगह ली 1 by omega c ने. So obviously by dimensions or by units it will be ohm. And cos omega t को फिर से sin omega t plus pi by 2. To compare it with the initial phase of voltage. Okay, so this is the resistance offered by capacitor. But ये resistor तो है नहीं, तो इसका नया नाम दिया XC और capacitive reactance. Capacitive reactance. It is equal to 1 by omega c. Obviously it's a resistance or its unit is ohm. So 1 by omega c is XC, and we can draw their graphs. Let's say on y-axis I show XC and on x-axis omega. So it's a rectangular hyperbola. जितना ओमेगा छोटा उतना XC बड़ा. जैसे जैसे ओमेगा बढ़ता है XC की वैल्यू कम होती जाती है. तो XC, the graph is rectangular hyperbola. Okay. We should also draw their phasors as, let's say this. If I represent voltage here, so the current which is omega t plus pi by 2, the phase of voltage was omega t only, तो current आगे है voltage से by pi by 2. Okay, this is pi by 2, this is voltage, and this will be current. Okay, और current आगे है voltage से by pi by 2. We can remember this word ice to just memorize कि कौन आगे कौन पीछे. In case of capacitive circuit, current आगे होता है, means current lead करता है किसको? EMF को, means voltage को. Okay, in case of capacitive circuit, current leads the voltage. Okay, अब कुछ क्वेश्चन लिए जा सकते हैं. एक कैपेसिटर है जिसकी कैपेसिटेंस लेट से 10 माइक्रोफेराड है और उसके अक्रॉस वोल्टेज आपने लगा दी 200 साइन 100 पाई टी. सो सबसे पहले हम ये निकालेंगे कि XC क्या है. XC इज 1 by omega c. 1 by omega is 100 pi, and C is 10 micro, 10 to the power minus 6. So how much is this? It is 10 to the power 3 by pi. This is the value of XC. So on doing this, I can get I as V0, which is 200 by XC, which is 10 to the power 3 by pi, sine of omega t, which is 100 pi t plus 90 degree. Because current leads the voltage across capacitor, this is the voltage across capacitor, or it is connected across an AC source whose voltage is given by this. And one more thing can be done. We can also draw their phasors in terms of sine graph or cos graph. If this is okay, so this is a voltage graph which is given by sine, and if I try to draw the graph of current, तो current होगा cos graph. Okay, let's say amplitude of current is more, so the graph will appear like this. I'm just drawing the points. Maxima, this, and this. Okay, so this orange is current and this is voltage graph. The line you should remember is current through capacitor through C leads the voltage across it, by pi by 2. Okay, so this is again very important line. Just remember this word, ice.